Hello everyone and thanks for watching Edupedia World videos. In this session of atomic structure, we'll study photoelectric effect. Alright, we'll see what do we mean by photoelectric effect. We have already seen that photoelectric effect led to the belief that electromagnetic wave can also act as particles. Okay, so let's understand in greater detail what this effect means. So the definition, you can say it simply means ejection of electrons whenever a beam of light strikes. Okay, for example, you have certain metals, for say you have sodium, alright, or you have potassium and so on. So whenever you have this metallic body here and whenever a light wave, okay, so this red color waves are your electromagnetic waves or light waves. So whenever such electromagnetic waves strike a metallic body, okay, they sometimes lead to ejection of electrons. So every metal, say sodium, potassium or whatever it is, every metal is basically an element, made up of an element, so it has electrons in it. Okay, they are all made up of atoms, they all have electrons in it, and sometimes those electrons can be taken out from them. So one way of taking out from those electrons from them is to simply have beam of light travel towards them and strike on their surface. Okay, so whenever such beams of light strike on metallic surfaces, it can lead to some changes. Okay, it may or it may not. Alright, and when it can also lead to ejection of electron from the metal surface. Alright, for example, your Na can get converted into Na positive by ejection of one electron if you have one single atom of sodium. Okay, so this ejection of electrons when beam of light strikes the surface of certain metals is basically called photoelectric effect. So it is like photo, basically referring to the light. Okay, so light leading to electricity. So whenever electrons are ejected, they can travel from one place to another. So this ejected electrons, if travel from one place to another, they generate electricity. Okay, electricity is nothing but traveling electrons. So photonic energy or photons leading to ejection of electrons. Alright, so that is photoelectric effect. So let's see what happens here. How does this takes place? Right. So we cannot understand this observation in greater detail without first understanding atomic structure, or at least the Bohr's model of atomic structure. Okay, but for now let's see it the way scientists saw it. Okay, when photoelectric effect first came, they did not yet completely understand the wave particle duality. Okay, Einstein only after observing photoelectric effect suggested and did further research in wave particle duality. Okay, though Max Planck had already given his theory, and in fact Einstein got a Nobel Prize for this study of photoelectric effect. Okay, he did not get Nobel Prize for the theory of relativity, but he got it for photoelectric effect. Okay. So what was the observations? First observation was there was no time lag between striking of light and ejection of the electron. Alright, that is to say, when the light waves struck the metal body, okay, it's not like you had to keep striking the beam of light for say continuously 1 minute and only then the electron was ejected. It was like either you strike the light and the electron will be ejected, or either you strike the light and electron will not be ejected. So when the electron is not ejected, even if you keep on striking the light for an hour or say even for a day or even for a year, the electron will not get ejected. But if you bring in another light, and that light, if it has to eject the electron, then it will do so as soon as it strikes the metallic body. Okay, it doesn't take a minute or a year or even a month, okay, or even a decade. Alright, it takes no time at all. So number of electrons is directly proportional to intensity of light. Alright, so we have already seen what we mean by intensity of light. Greater intensity means greater number of photons. Okay, so now here they are saying that if a particular light, okay, a particular light is going to eject the electrons, alright, then the number of electrons ejected will be proportional to the intensity of that incident light. Right. Next, the observation was based on threshold frequency. So what is threshold frequency? Well, let's represent it by nu naught. Nu is basically frequency, nu naught means threshold frequency. So the observation was that every metal has a threshold frequency. So what do we mean by this frequency? This frequency basically refers to the frequency of incident wave. So the wave coming here on the photons on the metal's body, okay, the wave coming here on the metallic body will have certain frequency. Okay, now like I told you that not all lights lead to ejection of electron. Some light may and some light will not. Okay, so why is it so that some light ejects electron and the others do not? Well, it is because the ejection of electron only takes place when the energy in the wave has at least a minimum value. Okay, to eject an electron from a metallic body you need energy. Okay, you need energy to separate this electron from this metal's body. Okay, for example, if you have a chocolate, you won't part away with it very easily. Okay, you will show some resistance. So similarly, the metallic body shows some resistance to give away the electron. It's like, why are you taking my electron? I want it. So you need to apply force, or you need to apply energy basically. So only when you meet a minimum amount of energy criteria, only when you exceed that threshold, okay, only when you exceed that threshold or minimum energy can the electron be ejected from the metal. Okay, so how do you impart the energy? The energy here is being imparted in form of light waves. Alright, and this light wave has energy dependent on its frequency. Okay, we have already seen that energy of wave is basically equal to h multiplied with nu. So the minimum energy required to eject the electron is equal to h into nu naught. And for each metallic body, this threshold frequency can have a different value. Okay, it can or it cannot. Alright, so we don't care what is the value, but we know that every metal will have some threshold frequency and hence it will have some minimum energy h into nu naught required to eject the electron. If the energy of incident light is below this threshold energy, then the electron will not get ejected even if you keep on striking the light for a complete day or complete year. But if the energy of incident light is greater than this threshold energy h into nu naught, then the electron will get ejected instantaneously. Alright, so this threshold frequency of the incident light, okay, this minimum frequency required of the incident light is called threshold frequency. Okay, so you can define it as the minimum frequency of the incident light which can eject the electron out of a metal's body. Okay, out of a particular metallic body. And whereas this minimum energy h into nu naught is also called work function of that metal. Okay, so you have to remember this term, work function of the metal is the minimum energy of the incident light required to eject an electron out of it. Alright, so let's analyze this photoelectric effect from a more mathematical approach. Okay, from a more mathematical perspective. So how does things work over here? See, you have electron, okay, embedded in this metallic body. Now we know that to remove electron we need specific amount of energy. Okay, and that specific amount of energy is equal to work function of the metal, or it is equal to h into nu naught. So only when the energy is greater than or equal to h nu naught will the electron be ejected. Let's say the energy present in my wave is equal to h into nu, that is the frequency is nu, so energy will be h into nu. Alright, now for observation of photoelectric effect, h nu must be greater than h nu naught, alright, or equal to h nu naught. And if h nu is less than h nu naught, then we cannot observe photoelectric effect. In this case, we will not observe photoelectric effect. That is, no electron will be ejected and hence no flow of current can be observed. But if h nu is greater or equal to, then we can see ejection of electron. So what happens if h nu is equal to h nu naught? Well, the light will strike the metallic surface, and you will, as soon as it strikes here, you will see an electron just lying here at the surface. So this electron has been ejected by the metal's body. Okay, it was forced to eject this electron. But what if h nu is greater than h nu naught? This means the energy that you are supplying is more than the required amount of energy. Okay, so the energy required to make electron part away from metallic body was only h nu naught. But if I am giving the metallic body some extra energy, where will that energy go? Well, that energy will not go to any other electron. Okay, so one single photon only interacts with one single electron. Okay, so this complete h nu energy will be imparted to this particular electron only. Alright, so the h nu naught will be the energy consumed by the electron in order to get away from the metal's body, and the rest of the energy left will be converted to kinetic energy of this electron. So it will keep on moving with velocity v. Alright, that is to say that h nu was the incident energy. So out of this h nu, the electron used up h nu naught amount of energy in order to get away from metal's body, and the rest of this energy, so this much energy is still left, so rest of this leftover energy is entirely converted into kinetic energy of the electron, okay, of the ejected electron. So kinetic energy of electron is half multiplied with mass of electron multiplied with velocity of electron. Alright, so from here you can also calculate the velocity of ejected electron. If h nu is equal to h nu naught, then velocity will be 0, but if h nu is greater than h nu naught, then you will get some value of velocity which you can very easily calculate. Alright, so remember this part, that one photon only interacts with one single electron. Okay, that is why when intensity is greater, now more number of electrons are ejected. A greater intensity means greater number of photons being incident on the metal's body. Alright, and greater number of photons incident will interact with greater number of electrons. Each photon will interact with one particular electron. Alright, and so all of those photons will lead to ejection of electrons if their energy is greater than work function. Alright, so that is why the number of electrons ejected is directly proportional to intensity of incident beam of light. Okay, and you also have to remember this equation, that h nu minus h nu naught is equal to kinetic energy of the ejected electron. Okay, that is all we need to study over here. Apart from this, photoelectric effect is something you will also cover in physics in even much greater detail. Okay, so that is all for now, and until next time, and once again thanks for watching Edupedia World videos.